Have you ever really stopped to wonder how an AI learns? I mean, really, truly learns. Well, it's not magic, that's for sure. It's this incredible process called backpropagation. This is the secret sauce, the core engine that lets a neural network go from just guessing randomly to making some seriously intelligent decisions. And today, we're going to break down exactly how it all works. We throw around the term AI learning all the time, but what's actually happening under the hood? It all boils down to this one question. When a machine gets something wrong, how does it figure out what to fix? And maybe more importantly, how to fix it? That's the real puzzle we're going to solve. Okay, so the whole process kicks off with what we call the forward journey or a forward pass. You can think of this as the network just taking its best shot at an answer. It's that moment where it looks at the data you give it and makes a prediction. Now, this forward journey has a few key steps. First, some input. Say an image, goes into the network. As it travels through all the layers, every connection has something called a weight, which is really just a measure of its influence. The inputs get multiplied by these weights, and the results are fed into activation functions. These are like little gatekeepers that decide if a signal is important enough to pass along. This whole thing just repeats until, boom, the final layer spits out an answer, the network's best guess. And, well, sometimes that guess is just plain wrong. Let's say we show the network a picture of a dog, but its final output says cat. This right here, this is the moment of truth. The network made a mistake, and believe it or not, that's a good thing, because now the real learning can begin. So the network guessed cat when the answer was dog. The next step is absolutely critical. We have to measure exactly how wrong that guess was. We need to put a number on it to quantify the size of the mistake. And the tool for that job is something called a loss function. It's basically a teacher with a red pen. It compares the model's prediction to the right answer and calculates a score for the error. A really high loss score, that's a big mistake. A low score means it was pretty close. The whole goal of training an AI is to get that loss score as close to zero as possible. And this is the million-dollar question, right? We've got this error score from our loss function. We know for a fact the network messed up. But where did it go wrong? Which of the thousands or maybe even millions of connections are to blame? How in the world do we adjust them so it does better next time? This is where backpropagation finally enters the picture. It's the return trip. It's the journey backwards through the network. So instead of passing data forward to get a guess, we're now sending the error backwards to deliver corrections. A really simple way to think about it is like this. The forward pass asks the question, and the backward pass, that's our backpropagation, corrects the answer. It's a full two-way street. One way to make a guess, the other way to learn from the mistake. So just imagine that loss score we calculated, that little signal of wrongness. It starts traveling backward from the end of the network, all the way to the beginning. And as it goes, it's like a detective, assigning a little bit of blame to every single connection it passes, figuring out which ones were the real culprits behind the final mistake. Now here is where things get really clever. The network doesn't just go in and blindly change everything. It has to be smart about it. It has to figure out which of its connections need a big adjustment and which ones only need a tiny little nudge in the right direction. And the main idea here is actually pretty simple. Backpropagation pinpoints which connections had the biggest impact on the final error. A high-impact connection, one that was a major reason for the screw-up, gets a big change. But a low-impact connection, one that barely affected the outcome, it gets a much smaller tweak. It's a super efficient way to get things back on track. Yeah, and this quote really just nails it. It's all about being strategic. The goal is to make the changes that are going to have the biggest bang for their buck in lowering that loss score. Backpropagation is just the math that lets the network figure out exactly how to do that. So when you put it all together, you can see the whole picture. This isn't just a one-and-done fix. This forward journey and this backward journey, they happen over and over and over again, creating this powerful learning loop. And this cycle is the absolute heart of AI training. You make a guess, you grade the guess, you assign the blame, and then you make the corrections. And then you do it all over again with the next piece of data. Every single time through this loop, the network gets just a tiny bit smarter. And I mean, this cycle is repeated a lot. We're talking millions, sometimes even billions of times. It's this relentless, repetitive process of guessing, checking, and correcting that takes a network from being a random guesser to being an incredibly powerful tool that can recognize your face, translate languages, or even drive a car. It's kind of a wild thought, isn't it?
We've just unpacked the learning mechanism for one single network. Now, try to imagine this fundamental process scaled up across the entire globe, happening inside billions of devices and systems all at the same time. That's the engine driving the AI revolution, and it all starts with one simple journey backward to fix a mistake.